Hi guys, today we're going to do Chapter 1, Section 3 in FST. Chapter 1, Section 3 is called Measures of Center, so we're going to be talking about mean, median, and mode, and we're also going to be talking about summation notation. Summation notation is something that we will be using later on, so it's important that you memorize what it is and how to use it, because we're going to be using it not only for means, but we're also going to be using it later on when we talk about standard deviation and variance. And then later on, way back in like Chapter 10, where we're doing lots of statistics. So the mean is the average value of a data set, and to find the mean, you add up all of your numbers in that data set and you divide by the number of terms that you had. The median is the middle value of a data set, listed in increasing or decreasing order. So the first thing you would do to find the median is put your data in order, and then you would find whatever's right in the middle. Okay, the mode is the value in a data set that occurs most often or most frequently. You can have multiple modes or you can have no mode. Alright, summation notation or sigma notation is written with this little E sign here. That stands for capital sigma. And this value here basically stands for a sum, which is why it's called summation notation. So remember from Algebra 2 that f sub 1 represents the first value in a data set, and its index, or the position of a number in an ordered list, is 1. So it's f sub 1. 1 is the index here. This is f sub 2, that represents the second value in the data set, and the index is 2. F sub 3 is the third value, its index is 3, etc., etc. So, with sigma notation, that gives us a symbol to represent the sum of an ordered data set. So if I say that f sub 1 is 3, f sub 2 is 10, f sub 3 is 12, f sub 4 is 2, and f sub 5 is 23, essentially what I have here is a set of numbers 3, 10, 12, 2, 23, okay, in that order. So what I can do is I can add all of those up, and when I do that, I get 50. So another way to write that would be in summation notation. What I can say is the sum from I equals 1, or my index of 1, up to 5, my index of 5 is where I end, of my f sub I values is going to equal 50. So the way I read that is the sum of f sub I as I goes from 1 to 50, or 1 to 5, is 50. Okay? So let's do an example. Let's say that my x sub 1 is 21, my x sub 2 is 27, my x sub 3 is 18, x sub 4 is 19, x sub 5 is 19, and x sub 6 is 20. Okay, if I want to find this value here, the way I'm going to read this is the sum of my x sub I values as I goes from 1 to 3. So essentially what I'm doing is I'm adding up x sub 1 plus x sub 2 plus x sub 3. Okay, well that's just 21 plus 27 plus 18. Okay, and when I add all those values up, I get 66. Okay, this one here, I've got the sum of my x sub I values from I equals 4 to I equals 6. So I'm adding up my 4th, 5th, and 6th values. So that's going to be 19 plus 19 plus 20. Okay, and that gives me 58. Okay, and the last one here is the sum of my x sub i's from I equals 2 to 4. So I'm going to start with x sub 2 is 27 plus 18 plus 19. And when I add all of those terms up, I get 64. Okay, we can also talk about mean in terms of summation notation. So I can talk about the definition of a mean in terms of my sigma. Okay, so the definition is actually written in your book, but I'm just going to write it up here instead. So if you have a data set with x sub 1, x sub 2, all the way up to x sub n, then we can say that the mean is the sum from I equals 1 to n of your x sub I values divided by n. So essentially what this is saying is if you add up all of your x sub I values and you're going from your index of 1 to your index of n, well, n would be the total number of terms that you have, so then you could just divide that by n. Okay? Another way to write it would be 1 over n times your sigma from I equals 1 to n of your x sub i's. Okay, so these are two different ways to write the same thing. Okay, both times we're talking about the mean of the data. And that is everything for section 3.